Assalamu alaikum. Inshallah, in this video I will try to squeeze all ideas of this lesson 5.7. So it's 5.7. It's exponential and logarithmic equations. We can say three main ideas: exponential equations with same base, different base, and logarithmic equations, as well as some word problems. Anyways, I'll go directly on solving the questions related directly to the concept of the lesson. So first idea we need to discuss is exponential equations with same base. So how can I solve an exponential equation, and how do I know that I have the same base? This term holding the power, this is a power, and this is called the base. So again, here's a base and here's a power. Now this is an exponential equation because the variable is in the power. Okay, it's not a normal quadratic formula or cubic formula. No, it's an exponential equation. Okay, so how do I know that I have the same base? Obviously just by looking at the question. So as you can see here, I have clearly the same base, and I have one side exponential expression equals another exponential expression, and both of them are having the same exact base 4. Now a very nice thing that I can do is just, if you have the same base in an exponential equation, you can cross out that base and say that the powers are definitely equal. So here I do have the same base, just cross out that base. Before that, you can't really solve the power. So this property is really good. Like you can't really add 5 minus 5 and do anything to the power. This is something untouchable. You can't really touch your power or do normal addition subtraction operation. So therefore this property is an amazing property where you get rid of the base, so your power becomes a normal expression. 2x plus 1 equals 3x minus 5. It's not a power anymore, it's just a normal expression. And then you solve normally with your own like based on however you solve your equations. Take the 5 here, it's gonna be positive 5. Take the 2x here, it's gonna be negative 2x. Now try to clean up this a bit. You're gonna have 1 plus 5 is 6 equals 3x minus 2x is an x, 1x. So x equals 6. Now please keep in mind that this case is only there when you have the same base, the exact same base. Now what do I do if I have such an example? I can tell clearly that the base is different. It's 5 and 25. But the thing is, you know that 25 originally I can write it as 5 squared. So this means there is a potential way of changing this base from being 25 into a base of 5. Now let's try to do that. I will replace substitute 25 as 5 squared, keeping in mind that I already use a power bracket please, that I already have a power aslan for the 25, so keep that power outside. Now there is again another nice property. As you can tell, I'm giving you a lot of properties. If you have a base with two powers, one of them inside the bracket, one of them outside the bracket, you can write it as one time the base with both powers multiplied. By the way, I kept for you many properties here. Tamam. So this means that you can still keep the base 5 and then multiply these. 2 times x is 2x. 2 times 13 is 26. See, I changed the 25 base into 5. And I can proceed, 3x minus 5. Just cross out that base, and now you have 3x minus 5 equals 2x plus 26. See, I was able to cross out the base and work with powers as normal expressions because I have the same base. So yes, now just proceed normally. Kick the 5 here, it's going to be positive 5. Take the 2x here, it's going to be negative 2x. Why is it always 2x? Now you have 3x minus 2x is 1x equals 26 plus 5 is 31. That's it. Easy peasy lemon squeezy. So yeah, you will keep on doing something similar to that. Sometimes you have to change both bases. For example, I'll do only this question and move on to the next idea. Again, both of these numbers, 1 over 2 and 4, are not the same base. But I know, like, with experience, you will get to know. Tamam. Later on, if you can't tell, I'm going to show you in the second idea how can you solve if you believe that they're not the same base and you can't really change that. I will teach you. But I actually taught you in class, but no problem. What will you do if you have different base, but there is a potential to change into the same base? Now I can see that the 4, I know, keep in mind that the 4 is 2 squared, obviously. And this is not 2. This is 1 over 2. Now there's a very nice property. I don't think it's here, but I'll write it here. If you have 1 over a, you can write it as a to the power of, it was power of 1, then keep it as 1, but with a negative power. So if you have 1 over a squared, it's going to be a to the power of negative 2. 1 over a cubed, it's going to be a to the power of negative 3. So this is how you rewrite a fractional term, like a fraction. But it should be, the base should be 1. That's a quick hack. So 1 over 2, I can write it as, you will see like 2, 3 examples, same as this idea in the book. As keep the number 2, and there was a power of 1, so it's going to be stay power of 1, but negative. Anyways, I can rewrite both into a common base. See, I will have to sometimes change both sides into a common base. Yani sometimes you don't change the 2 into 4 or 4 into 1 over 2. No. Both of them are going to change into 2. This one to the negative 1. Obviously, there is another power, x plus 4, x plus 7. And the 4, I will change it to 2 squared. And obviously, I have an original power outside. See? I did actually change both bases. Now, just don't forget power of power, make sure to multiply. So it's going to be 2 to the power of negative 1 times x is negative x. Negative 1 times 7 is negative 7. Same here. 2 times 3x is 6x. Please make sure to multiply. A common mistake, students will forget to multiply the number with both. They will most probably multiply it with the first term. Please pay attention to multiply it fully. Now, since I have the same base, cross it out and proceed normally. Negative x minus 7 equals 6x. Take the x here. It's going to be positive x. Now, negative 7 equals 6x plus x is 7x. And then divide by 7. X equals, this is negative 1. That's it. Very easy, very simple, straightforward. This was an idea أصلا you took in grade 9. I believe it's going to be a very simple idea for you all. But you will see me jumping right away to the next idea. Please make sure to solve reasoning questions yourself. This question is supposed to be in the next idea. Same as this one. Yeah, here as you can see 4 and 16. 16, I know it's 4 squared. So I can tell that I'm going to rewrite the 16 as 4 squared. Still there's another power outside. And the 4 is going to stay as it is, 3x minus 1. Then you will multiply these. 4, 2 times x is 2x. See? And then just remove the base and proceed solving whatever. Tamam? Anyways, I will solve word problems in like last slide. So, next idea is solving exponential equations with different base. What if I have a different base? Now, before we proceed with this thing, I want to, again, please explore these ideas. I think you will have to change both of them into 3. This is 3 squared, 9 is 3 squared. Obviously, keep the power. And 27 is 3 to the power of 3. 3x minus 4. With experience, you will have the fluency to tell quickly. Like here, I believe this is 2 to the power of something. But personally, I will just keep on guessing 2 to the power of 3 on my calculator until I get this number. If I did not get it up to 2 to the power of 7, maybe 7 is huge. But yes, I think I will give up and try the next idea. Anyways, now what if you have different bases and you know that there is no way you can rewrite them into the same base, what will you do? Now there is something, a very nice concept actually to do before we start. You have to keep in mind, if you know that a number is equal to another like whatever number, like as you can see 8 is 2 to the power of 3, they are equal. The idea is taking log of both sides, log or len, doesn't matter, just taking the same logarithmic function on both sides will give you the same idea. Yani if you put log 8 in your calculator, I think you're gonna get 0.93 whatsoever. And also if you put this one in your calculator, this whole term in your calculator, you will also get the same exact number, which are equal. This means if you have two things that you believe that they don't have the same base, or two quantities that are supposed to be equal, then their logs are equal. Why is that helpful? It's very helpful to allow us to solve such problems. So how can we use that? If you can see here, I have 5 and 3. They are different base and there's no way they're going to be the same base. What can I do? Use this idea, use this property, which is take logs of both sides. So take log of 3 to the power of x plus 1 and log of 5 to the power of x. Now after you took log of both sides, there is a very nice property in logarithm that we will keep on using in such problems, which called the power property in logarithm. Let me just go back again. There is a very nice property, says if you have log of something with already a power here, you can drag that power outside and have it multiplied with the logarithm. This property will free our exponent. Like this will allow us to take the exponent outside the logarithm and like allow us work with that variable. Before that, we were not able to touch the variable. So it's going to be x log 5. X, take it out, just multiplied basically. This is what I mean by pull it out. It's just multiplication relationship. And same here, x plus 1 multiplied with log 3. Please notice that I put a bracket here because I have two terms. This means that I need to multiply the log 3 with both. X will be multiplied with log 3 and 1 will be multiplied with log 3. So how can I do that? Just each one will take log 3. It's going to be x multiplied with log 3 plus 1 multiplied with log 3, which is log 3. No need to write the 1. Yes. So if you have two terms, then you have to distribute the log. Here I have only one term, that's why I was not, it wasn't really necessary to put a bracket. Now as you can see, I have variables, I have like some ugly logarithmic terms. I can do something. I know that this is a variable because there's a variable obviously. This is also a variable and this is a number, by the way. Log 3 is a number, it's 0.447 whatsoever. If you want here to change these into decimals and proceed with decimals, go ahead. But most probably you will face some like cases where you need to keep it as a logarithm, and please learn how to keep it as a logarithm. So how can we do that? Just take this variable term to the left side. It's gonna be negative x log 5. And take this number term to the right side, like put the variables together and numbers together basically. If you take this number here, it's gonna be, it was positive, it's gonna be negative log 3. And this term did not change, we're still having it in the left side. So it's gonna stay as it is, x log 3. I think we will need to go. Okay, now from here, what can I do? Can I actually subtract these? No, but you can do something nice. You can pull out the x as a common factor. So it's gonna be x outside. Just take the x as a common factor. x outside, and then you open a bracket, and inside the bracket you put everything left, because you took the x from both logs. So it's just like you're saying that x is multiplied with each. Okay, log 3. And why did I do that? So I end up with one variable, and that's how you solve equations. You have to gather all variables together and write it as one variable, obviously. طيب, x is multiplied with this bracket. How do we cancel that bracket? I want x alone. So you just divide by the same term. 5 cancelled, divide by the same term. I know it's a long process of solving logarithms, but at least it's solvable, alhamdulillah, thank God. X equals this thing, which is log 3 over log 3 minus log 5. That's it. Put this in your calculator. I think you're gonna get, by the way, once you are putting logarithms in your calculator, make sure to close your bracket of each logarithm, because obviously the calculator will not close it for you. It's gonna be, if you put this in the calculator, it's gonna be x equals negative 2.15. That's it. And this is how you solve exponential equations with different base. Very easy, but it's just like the same steps every single time. طيب, let's take examples here. These are 3 sort of different ideas, and I don't think you have any other ideas in the book. Actually, you don't. You only have these 3 different ideas, but all of them can be solved with the same concept. Take log of both sides. طيب, how does it work? So this example, again, it's the same as before. 2 to the power of a variable equals to 7 to the power of a variable. And both bases are so not related. You can't write the 7 as 2. You can't write each one of them as anything related to the other. So what can I do? Just as I said, if you have a dead case, you don't know what to do, just take log of both sides and pull that power out. So it's gonna be log base 2 of 3x equals log 7 to the power of x plus 1. Did I say base 2? No, it's base 10. Anyways, now what can I do? Just pull the power out, as we said before. So it's gonna be, see, this property is really good. It allows you to like have to work with the power, the variable. It's the whole problem is that the variable is in the power. This property allows us to pull that variable down and work with it. طيب, here just multiply these. Miss, how do I multiply this? Please don't multiply the 3 with the 2. The 3 is a number bin alam unas. Leave it alone. The 2 is a number inside the log. Don't multiply it. Just leave it alone. Leave it as 3x log 2. You can pull the 3 as a power for the 2, but don't do that. No need to do that. Already you're gonna put it all in the calculator. No need. Anyways, here I have 2 terms, then each one will take log. Miss, why didn't you distribute here? Because I only have 1 term, but here I have 2 terms because there's an addition between them. Therefore, I know they are 2 separate terms. This is 1 whole term. Anyways, it's gonna be x log 7. Each one will take log 7. And then 1 times log 7 is just log 7. And now put all variables together. As you can see, this is a variable, a number. So take the variable to the left side with the other variable. It's going to be negative x log 7. Don't blink أصلا while solving these questions. Avoid blinking, لأنه any mistake you can do, you're going to get confused. Like, try to double check that you're copying the correct numbers. Did I put the same correct term? Yes. Did I put the same sign? Yes. Did I flip the sign? Yes. Keep on checking. طيب, what do I do here? Again, I need to put the variables all together. I can't really add them, subtract them. Don't write it as 2. Like, don't do 3x minus x is 2. Don't do that. You have different logs. You can do that. So just take the x as a common factor. عادي. You can take the x as a common factor. I swear to God. And open a bracket with everything left. You still have a 3 log 2. See, I kept the 3. ما خربت الدنيا. And then log 7 equals, on the other side is log 7. Now what do I do? Sorry. Get rid of this. Just cancel by the same thing. Since x is multiplied by a very long bracket, just cancel that long term by dividing both sides with it. So divide by 3 log 7 minus log, see, I made a small mistake. 3 log 2 minus log 7. Make sure to double, don't blink. I think I did blink here. So the answer is log 7 over 3 log 2 minus log 7. I explained this in class multiple times during online and in class when we were back. Yani, I really hope that you guys can put the same effort while you are watching the videos in class. Wallah, you will learn more. Sometimes I say more helpful things in class. Minus log 7. If you put this whole term in the calculator, you can get 14.57. That's it. That's the value of x. Yeah, this whole thing is 14.57. Anyways, what if we have such a thing? This type of questions is way easier. Again, as you can see, I have 10 to a power of x plus 2 and 78 to the power of 1. There's a hidden power 1, or like just 78. This type of problems, you can, if you want to change from exponential form to logarithmic form, you can do that because you only have in one side x. The other one doesn't have an x. So you can say log base 10 of 78 equals this. You can do that. But again, I will stick to this method because I really want you to practice doing this method. Again, what do I do? Since they are different base, just take log of both sides. That's it. Very easy. Also, this type of question is way easier when you only have one variable. So it's again log 10x plus 2 equals log 78. Now what do I do? Just pull out that variable. Here I don't have a power, alhamdulillah, only here. So it's gonna be x plus 2 inside a bracket. Please keep in mind to use a bracket so that you remember that you need to distribute. And then distribute. So each one will take log 10. It's gonna be x log 10 plus 2 log 10 equals log 78. Now what do we do? Take this whole thing to the left side. It's a number. So it's gonna be log 78 minus 2 log 10 equals x log 10, and then just divide by log 10. Divide the whole thing by log 10. It's gonna be x equals log 78 minus 2 log 10 over log 10. You can do this method, or in class I taught you a way easier one, million مرة easier. This method is efficient. You can always use it. Log on both sides. By the way, it works even if they are the same base. It works always. But I taught you in class another method for such questions when you only have one variable, and it was very easy. Still, again, I'm not going to discuss it here. If you want to know about that, I will teach you in class. Teach you like on the side. Ask me, no problem. Anyways, so now what do I have in this example? Here is one more idea. It's all the same method. I have 3 terms. يعني what should I do? Look, as you can see, the 4 and the 5 are not exponential terms. They're just normal numbers. So if I take the 4 to the other side, with the 15, sorry, the 4 to the 15, it's gonna be -4. So you're gonna end up with 5, 6 to the power of 6 minus x equals 15 minus 4, which is, let me write it down here, 5 to the power of 6 minus x equals 15 minus 4 is 11. Is it? Yeah, it is. Now you can work normally as previous questions. It's not the same base. So what do? Just take log of both sides. Oh my god, you would have been very lucky if it was, yeah, if this was 10, you will end up with 5 on both sides. Just cross the 5 and whatsoever. Anyways, now what do? Just work with log on both sides. Again, here you have a power, pull the power out. It's gonna be 6 minus x times log 5 equals log 11. There is no power, just write as log 11. Here, distribute the log 5. Each one will take log 5. حاسة حل مليت from solving such questions والله. Minus x log 5 equals log 11. And then there are only two terms that are numbers and one term only that is a variable. So just kick the number to the other side. It's gonna be negative 6 log 5. Just let's clean up a bit. We have still negative. Can you see that? Please don't forget the negative. Please, please, please. Negative x log 5 equals log 11 minus 6 log 5. طيب, now how can we cancel this? Just divide by it. Divide by log 5 negative, so that the negatives will like cancel out and you end up only with x, and the logs will cancel out. Can we divide by a negative? Yeah, it's just like you are dividing by negative 1. Same concept. Anyways, yes, negative log 5. Now we have only x equals this very ugly nice term. I think it's more ugly than being nice. Log 5 على negative log 5. بس fun, super fun, way more fun than I expected. ما شاء الله. مش عارفة شو بحكي صاير أصلا. 6 log 5 and then negative log 5. That's it. Put this in the calculator, you will get x equals 4.5. A lot of 4s and 5s. 5s كتير. بس very easy, super easy, smooth, amazing. بس خلصنا. That's it. So these are the logarithmic, the exponential equations. To be honest, this one, you can take log of both sides, but I personally would do it in a different way. Again, log both sides. I taught you guys in class how to do it in like a way easier method, but still it's correct. Both of them are correct. Yes, so I think I will discuss this method here for this example. Let's see. So they're saying why logarithms are necessary to solve equations like this one, but they are not necessary to solve equations like this one. As you can see, this equation, I have the base is 3 and the other side it's 8. I can't really write them as the same base. So I need to take log of both sides in order to solve such a problem. But here I have 3 and 27. They look the different base, but 27 I know it's 3 cubed. So I can rewrite it as 3 to the power of 3 equals 3 to the power of x plus 2, and then distribute the power. 12x equals 3 to the power of x plus 2, and cancel out the base. See, I was not even expecting using any logarithm here. Just normally solve it. No need for any logarithm. But here, since they are different base 8 and 3, I can't really change the 8 to become 3. Nothing to do, so take log of both sides, yes. This question again, 7 to the power of x equals 3. Take log of both sides. Now what do? Pull out the x. It's going to be x log 7 equals log 3, and divide by log 7 to cancel it. Now you have x equals log 3 over log 7, which is this one. Easy, very easy. Again, word problems I will be discussing in the last idea. Finally, we are here. So logarithms, last idea. What if I have a logarithmic equation and some real life problems? What if I have a logarithmic equation? So let's take, for example, this is not a logarithmic equation. This is an exponential equation. This is logarithmic equation. So just to keep in mind, if you have powers and exponents, that's normal exponential equation. If you have logarithms, then that's an logarithmic equation. So what if I have logarithmic equation? Again, going back to the previous property that I said, if you have 8 equals 2 to the power of 3, then log 8 is the same as, what am I writing? Log 2 to the power of 3. And not only log, you can use len. 8 is the same as len 2 to the power of 3. Not only len, log base 10 base 5 of 8 is the same as log base 5 of 2 to the power of 3, as long as you're using the same log. Now, how is this related to this equation? Let's see. So first of all, I can see clearly that both sides, they do have logs, but this one have number 2 extra. Just pull the 2, it's a power, remember? It was originally a power for x. So remember when we have the property where if you have, let's say, squared, you can pull the 2 outside? Yeah, and then you can also pull back the 2. Why would I do that? Just to end up with something like this, 5x minus 4. As you can see, I have both sides. Log of a term equals log of another term. This is very familiar here, right? Since I have one log from one side equal another log from the other side only, without any number, without anything, even the number we pulled it inside as a power. Tamam? Now what can I do? Just cross out the log and work with what's inside it. You can say that what was inside the log is equal to what was inside the other log. Same concept as the previous one. Previously we used to put the logs. Now we are taking out the logs. Yeah, because as you can see, the x is inside the log. It's inside the log. So we need to take out the log, cancel it out, so we can work with variables normally. Yes, anyways, now what can we do? Just take everything to one side, solving normal equations. X squared minus 5x plus 4 equals 0. Put this in your calculator, mod 5, 3. You will get A is 1, B is -5, and C is 4. First, the answer is x equals 4. Second answer is x equals 1. Now the thing is, you can't only list for me the answers like this. You still have to do another, like one more step, which is check your solutions. Because sometimes I get solutions that are extraneous. And what I mean by saying extraneous is some of these solutions, if I substitute them back in the equation, they will give me an error, or both sides will not end up being the same. Like I will face some problems because they are like solutions for this equation, not necessarily the original equation. Okay, so one of them, or maybe none of them, is gonna be an extraneous solution. Let's check. How do we check? For example, if I want to check, by the way, this is the only time where I'm gonna explain how to check extraneous solution. Check extraneous solutions. Later on, I will only tell you check extraneous solution. You should know how to do that yourself. Again, how to check extraneous solutions. Let's say we want to check x equals 4. If it's an extraneous rejected solution or a normal real solution. So how do we do that? Take the original equation, 2 log x equals log 5x minus 4. And then substitute your x with 4. So it's gonna be 2 log 4, see, equals log 5 times 4 minus 4. Now how do we do that? Take this separately in the calculator. Please make sure to keep the bracket closed. Use like proper, keep in mind to close the brackets. Anyways, 2 log 4, close the bracket obviously. You're gonna get, this side I got 1.204, okay? Now do the same for this one. So you're gonna evaluate each side separately and check are they gonna be equal. That's it. This is how you check extraneous solution. Very silly. 5 times 4 is 20 minus 4 is 16. But don't do mental math, please. Like, don't trust your mental method in the final, or you can do that if you want, just up to you. 1.204. Yes, I got the same answer. Since they are equal, then it's not extraneous, it's a real solution, not extraneous. Let's check the other one. So you will do the same thing for all solutions on that you got. I got x equals 4 and x equals 1. So do the same for x equals 1. Again, 2 log, substitute the x with 1. Check is it equal to log 5 times 1 minus 4. And put this thing in the calculator. 2 log 1 is 0. So definitely 0. By the way, log 1 is always 0. Equals, so 0 times 2 is 0. Anyways, log 5 minus 4. 5 minus 4 is 1, which is going to be 0 as well. So no problems in this example, alhamdulillah. So yes, if you put this in your calculator, also you're going to get a 0, which is equal. They are equal to each other. That's correct, no problem. So this is a real solution, no extraneous solutions. I promise there are some cases in where they are extraneous solutions. Both of them are real solutions. Tamam? I think I'll keep on checking both until I get something. Anyways, let's solve this question. Here, as you can see, I have len, a term, equals len, another term. I can easily just cross out the lens because there's no number before, no number after, only len a equals len b. Then you can cross the lens and say equals b. Or if you have log a equals log b, you can cross out the logs and say a equals b, and so on. Anyways, yes, so after crossing out the lens, you will have x squared minus 16 equals 6x. Put everything on one side. It's going to be x squared minus 6x minus 16 equals 0. I prefer to keep it in standard form. That's why I put the negative 6x in the middle. Now use mod 5, 3. So to factorize or to find the solutions, your a is 1, your b is negative 6, your c is negative 16. First solution is x equals 8. Second solution is x equals negative 2. Now if you check extraneous solutions, again, check extraneous solutions. How do we do that? Just substitute the 8 back in the equation. So you're going to say len 8 squared minus 16. Is it the same as len 6 times 8? So this is how you check. By the way, I put double bracket because there's a bracket for the 8 and there's another bracket for the aslan, the whole term. So you're going to go like len 8 squared minus 16. And see what's the answer. It's 3.87. And the other one, check the same case. Len 6 times 8, which is also the same answer, 3.87. Since I got the same answer, then it's a real normal solution, no problem. Now let's check negative 2, same concept. How do we check negative 2? Len, I said that I'm not going to do that. Use a bracket for negative 2 when you want to square it. If you don't use a bracket, they will square negative 2 as negative 4. But if you use a bracket, they will square it as 4. And negative 2 squared is 4. It's not negative 4. So please use brackets. Tamam? Anyways, minus 16 equals, check, is it equal to len It's 6 times x. Our x is negative 2. So 6 times negative 2, which is negative 12. So let's see, are they equal? Then the first one, 4 minus 16, is, oh, that's, aslan from here you're gonna get an error. By the way, logarithms take only positive numbers. You can't really find a log of 0 or anything negative. So once you see yourself putting inside the logarithm a negative number, definitely it's an extraneous solution. Like, it is a solution for this equation, but it's not a solution that the log will take, you know? So since you got a math error, once, like, I put this in the calculator and I got math error. And math error, not because I forgot a bracket or something. I checked all brackets, everything is fine. So definitely it's a math error because the logarithm cannot take a negative number. So this is an extraneous solution. Very nice. حبيت. Very nice. طيب. I want to move on from this idea. خلصت, I'm so done. There is one more logarithmic equation idea, which is, I don't know why didn't I put a clear example here. I put just this one down here. طيب. Let's do this question together. How can you use properties of logarithms to solve such an equation? So first of all, this is an equation of logarithm, but I don't have log on both sides. Now in this case, when you have log of base for a term a and equals to an answer, you can't really cross that log. This is called the logarithmic form, log form. You can change it from log form to exponential form. How to do that? I kept for you a note, by the way, again here. This is how you change from log form to exponential, from exponential to log form. Just keep in mind that you're gonna use it forever. So please make sure you do know how to do that. So I will do a quick something here. This is the base b, so you're gonna write the base b. This is the power c, and what's inside the log, you take it out. That's it. So same concept here. Base is 6, done. Power is 12, and what's inside the log, I will take it out, all of it as it is. That's it. This is how you solve it. Since there is no logs on both sides to cancel out, I can change from log form to exponential form. Again, why didn't I cross out the log? Because I don't have another log. That's why I had to go to basics. This is a basic thing, by the way. You should know how to change from log form to exponential form. Now, how do we do that? Just how to cancel power of 3. Just take cube root on both sides. So you're gonna end up with 8x minus 2 equals, put this in your calculator, it's gonna be 6 to the power of 4. 6 to the power of 12, all of it under the root. Take away the root 3 of 6 power of 12. Yeah, it's 1296. 1296. And now take the 2 here. It's gonna be positive 2, which is 1298 equals 8x. Divide by 8. Just divide by 8. It's 162.25. That's the value of x. Again, you have to check extraneous solutions. Just plug this back in the equation and see if you get any error. You're not gonna get an error, but it's a real solution, but you can check yourself. Anyways, how can I use properties of logarithms to solve this? So I solved it the normal way. How can I use properties to solve it? There's another way which I can use. You're gonna get the same answer, but you will use properties of logarithms. Let's recall properties of logarithms a little bit. So as you can see, I have a power property, product property, quotient property when you have division between two terms, and power property. So which one I can possibly use? I don't have a product, I don't have a quotient, I have a power. So the power property says if you have a power, just pull it out. Let's try to do that. 3 log base 6 of 8x minus 2 equals 12. Can I change now from logarithmic to exponential? Not really, because I have a number here. I need to cancel it out. So let's cancel 3. How do we cancel 3? 3 is multiplied with the log. So just divide by 3 to cancel out from both sides. You're going to end up with log base 6 of 8x minus 2. See, without a power. 12 over 3 is 4. Now what can I do? Now you can change from logarithmic to exponential. So it's going to be 6 is the base, 4 is the power, equals 8x minus 2. See, I have directly 6 to the power of 4 instead of this. And I have this one with the power of 3. Just 6 to the power of 4, by the way, is, guess what? It is 1296. Which is the same exact thing we got here. Just take the 2 here and do the same thing. X will give you the same exact answer. بس خالص. That's it. Yes, so here when you have 2 logs, you need to combine them. Put them together using a product property. Always go back to the slide. If you have 2 logs, you can write them down as 1 log and just multiply what was inside them. Let me do this question with you somewhere here. So this is a very long video. Now what do we do? Again, since I have 2 logs, please don't rush into crossing them out. Like, they're added. You can't really cross them out. It should be log of something equals log of another thing. They are added. They're not equal to each other. So you can't cross them out. What can I do? If you have log of one term equals to plus log of another term, it's the same as log of the first times the second. Just multiply the terms. Okay, so put these 2 as 1 log, base 2, 1 log only, and just multiply these 2 terms. X times x minus 3 equals 2. Now, how do we multiply them? Normal multiplication. Why am I asking C questions? Anyway, x times x is x squared minus x times 3 is 3x equals 2. Now again, since you have a log equals a number, you can't cross that log out. What do? Change from, it's the same as this idea. Change from log form to exponential form. So it's going to be 2 is the base, 2 is the power, what a coincidence, x squared minus 3x. 2 squared is 4. Take the 4 here. It's gonna be x squared minus 3x minus 4 equals 0. Put this in the calculator. Mod 5 3. You will get negative 4 positive 1, I think. Negative 3, negative 4. Yes, negative 1 positive 4. X equals negative 1. The other x equals positive 4. Please don't stop here. Put it back in your equation to check. So how do you check extraneous solutions? Again, take your original equation, log base 2 of x. now check -1. أول ما تشوفي حالك حطيتي inside the log a negative number directly, that's a very red flag, very extraneous solution. مش بس extraneous, هذا extraneous مرتب. if you put this in the calculator أكبر math error حيطلع لك بحياتك. that extraneous solution, math error. So extraneous solutions are there when you have an error. Error means like you can't really plug this number inside the function. Or when you have two sides that are not equal. So this is an extraneous solution. This is not a real accepted solution. That's a rejected solution. How do we check the 4? Take again log 4 plus, by the way, I'm not coming up with this. I'm just taking the equation. Instead of x, I'm substituting 4. Now put this in the calculator. Log base 2 of 4 is, I think, 2. Please make sure you know how to use a customized log and normal log on your calculator. You need to make sure you do get that before you go to the exam. This is 0. Oh, that's because 1 equals to, is 2 plus 0 equals 2? Yeah. So that's a normal accepted real solution. See, that's it. I will stop here, to be honest. Please make sure to solve real error analysis questions. Make sure that here at the power you should bring it back in before you cross the logs from both sides. Another video I will do only for word problems because this video is very long. So the last idea of word problems in this lesson, or should I do that now? I think, let me do that now, no problem. I will do the rabbit question. I will start with this one. Yalla, bismillah. So the last idea is how can you use logarithms to solve some exponential problems? This is very related to lesson 5.1, which is already in the final. But let's see. A fish pond had 350. Let me just break down for you something. In lesson 5.1, we have a decay function and growth function. يعني بدون ما أطول عليكم, decay function is a function of time. By the way, it's always time, months, years. This is how you write it, and we always use it. It's initial value, we call it A, just the initial value or starting number or initial value or whatever. If it was a decay, it's gonna be 1 minus a rate of decay, which is a percentage usually, to the power of time. Years, months, hours, days, it's just a time. Okay, it's always like this. If it was a growth function, again, it's a function of time, not necessarily f of x, n of t, f of t, g of t, whatsoever, equals initial value, again, 1 plus a rate of growth to the power of t. The same rate, just they have to tell you in the question whether it's a growth case or a decay case. Let's see how can we do that. So let me just remove this. Now they said that a fish pond had 350. This is the initial value, that's your A. In 2018, don't rush and say this is T. This is not T. T is number of years that the whole thing is growing throughout how many years. This is what T. So, and then they said the number of fishes increases. So that's a growth problem by 18%. This is your rate every year. How many fish will be there in 2030? So as you can see, number of years T is from 18 to 30. So how many years you have from 2030 to 2018? Take always big number minus smaller one. Please make sure to keep in mind that years are always positive. Don't go and write in the example negative power and expect you get a good mark. Seriously, years are always a positive number. Even if you did subtract this, like by mistake, smaller one first, you will get a negative 12. Please make sure to use positive 12. Anyways, let's put our function together. So our function, which is number of fish over years, equals initial value 1 plus, by the way, I'm just copying the growth function. This is the growth function. Why did I use this function, not the decay one? Because they said it increases. Now let's put in whatever we have. We have number of years is 12. We have initial value is 350. And we have the rate is 18%. Please change it to decimal. So put 18% in your calculator, or if you know how to change percent to decimal, you're gonna get just 18 in a decimal point. If it was 5%, it's gonna be 5, move it twice, decimal point. If it was 50%, it's gonna be 50, move it twice. This is how you change from percent to decimal. This is the rate. So the rate I wanted in decimal. Now plug it in, that's it. A is 350, 1 plus 0.18, power is 12. So put this whole thing in your calculator. 1 plus 0.18 is 1.18. 50, 1.18 to the power of 12. That's the function. Put this in your calculator to find how many fish will be after 12 years. It's gonna be 350 times 1.18 to the power of 12, which is 550.65. But you can't have a 0.65 fish, so you can say 2,550 fish. Sorry, this is the number of fish. That's it. Very easy. But make sure to show me the decimal number, and then give your conclusion. I'm done with this lesson. I'm so done with this lesson. This is another example where you have a rate of growth, because they said increases, number of years whatsoever. That's it. See you inshallah in the next lesson video. You can check the answer key for guidance while you are solving the questions. Make sure to solve all questions, and good luck.